Oh, hello Internet. My name is Quinn and this is Blondihacks. This is my roughly annual Q&A episode where I get my patrons to ask a bunch of their most burning questions, some of which might need medical attention, but hopefully they're questions that you have as well, and I'll answer them as best I can. I'd like to start this video with a tribute to Cherry Hill, a legendary British model engineer whom we lost on the 13th of December of last year. She was 93, so she had a heck of a run, and she was a real inspiration to me and really an incredible craftsperson and someone who I think not enough has been written or said about, so I wanted to mention her here. She won 9 gold medals at the annual London Model Engineers exhibition, and the top British model engineering award is the Duke of Edinburgh Award, which she also won 9 times. She was known as the Fabergé of model engineering, and if you've seen her models, then I think you would agree. There's a wonderful book that's been written about her and her models, and I'll link to that below. I definitely recommend you check it out. Not only was her craftsmanship just flawless, but she chose really interesting subject matter. Just things like that. She built stuff that nobody else built, and to a level of quality that I can only aspire to at this point in my model engineering journey. So thank you, Cherry Hill, for the inspiration. First and foremost, the most important question: hockey or curling? I mean, why not both? I did play a lot of hockey in my misspent youth. I have 2 ruined knees to prove it, and I've never actually done curling, but I love to watch it. It's one of my favorite sports to watch, and I definitely would like to give it a try. You know, I used to get into arguments with my American friends all the time about sports. Why is your ice green? It doesn't make any sense. When going through the design process, how do you approach the problem? Do you prefer to play it safe and defer to the books, or do you go off on your own with other designs? My rule of thumb is always that everyone who came before me is smart and probably knows more about the problem than I do. So I'm always going to start with the experts who've come before. If I'm going to build, I don't know, a toolmaker's clamp, and I'm going to look at the designs in the books for it, look at the ones that exist, and I'm probably going to start with someone else's design, because that person who has designed this and built this and has created something that we know works has solved a lot of problems that I don't know they've solved. You know, when you start something new, you don't know what you don't know. And I think a position of humility is incredibly valuable. You should go in assuming that the people that came before you know things about this problem that you don't yet. And you're going to find that out the hard way if you just try to go off on your own. Now, that said, once you've built a few things and followed the rules of the experts, then you can start playing with breaking the rules and innovating a little bit. Because, of course, innovation is important too, but you got to learn the rules before you should start breaking them. I'm interested in the business and economic aspects of the YouTuber life. This channel has no ads and no sweaty clickbait flavor on anything. Sweaty flavor. Best not to think about that one too much, which is unusual. I guess it is unusual. You know, this is something that's pretty important to me. I always wanted to avoid heavy sponsorships and ads and merchandising and all of the things that most YouTube channels are kind of full of. There are a lot of different business models that can work on YouTube, and success in this space is very much a function of finding what works for you and your audience. You know, I don't fault other channels for doing a lot of the things like that I don't do, because that's working for them and that was necessary. I'm very, very fortunate in that I've found a community of patrons who are willing to fund this content directly. And, you know, I recognize that that's a luxury that not everybody has. So, you know, for me, it was a case of, if I couldn't make it work this way, I wasn't going to do it. I really didn't want to get into pushing t-shirts on you all the time and reviewing merchandise sent to me by sponsors and all of that kind of stuff. Which is not to say I never, you know, build kits that companies have sent me. You've seen me do that, but it's not a focus of the channel, and it's not something that I want to drive the finances of the channel. So it's very much viewer funded. I guess it's sort of a public broadcasting model, if you like. Maybe I should start sending you all tote bags. I don't know. How does that work? But like I say, I'm fortunate to have a business model that's working the way I really wanted it to. And you all are the reason for that. So thank you. What are the unsung heroes of your shop that make your machining time more pleasurable, such as stools or sound systems? Those are good examples, because those are 2 things on the list. I do have a stool which I use primarily for if I'm doing fine detail work, like a lot of needle filing or fit and finishing when you've got to get in close. I find that easier to do sitting down. I also have a sound system in the shop, which is just an old iPhone sitting on a dock in the corner of the workbench, and I've got one of those cheap Class D Amazon amplifiers and a couple of old speakers, and it works great. I mostly listen to podcasts, honestly. If I'm doing something repetitive, it's nice to have something, that kind of keeps my mind busy. I listen to science podcasts and pop culture stuff, the usual things, and that really helps pass the time. The other big unsung hero you'll see in the top left of all of my intros, and that's the mini split heat pump. If you have not climate controlled your shop, I cannot recommend that highly enough. Nothing will make your shop time more enjoyable than making it feel like indoors in there. The mini split heats it up in the winter and cools it down in the summer and controls the humidity and just really makes it incredibly nice in there all year round. That combined with insulation, of course, you do have to have good insulation for a heat pump. And the walls are also very barriered, which helps. And the floor is painted, which also helps a lot. Concrete makes a lot of humidity. So if you can paint the floors or epoxy them or something, cover that concrete any way that you can will help as well. And that just makes the atmosphere in the shop nice. It makes a huge difference. If someone wants to get into steam engine stuff, where's the best place to start? What should their first and second projects be? Well, the absolute first steam project that anyone should build is a simple bar stock wobbler. And in fact, I've got a series of blog posts on building one of those, which you can find on my blog at blondihacks.com. I'm going to be doing a video series also. I've been working on a design for a very beginner-friendly wobbler steam engine, so I'll be doing a video series on that pretty soon. And then your second project should definitely be a simple stationary engine casting kit, something like the PM Research PM1 engine, or Stuart, if you're over in Europe, has some really nice beginner models as well. The reason those models are great to start with is because a simple stationary single-cylinder steam engine is very, very forgiving. If you don't get the tolerances right and your bearings aren't well made and your valve timing is bad and all the rest of it, it still runs. As we say in model engineering, they always run. That's the nice thing about steam engines and why steam is such a good fit for hobby machining, is because, while the tolerances are important, you're going to end up with something that runs. The better made it is, the more efficiently it will run. It'll run quieter and use less fuel and run on lower pressure, but it'll always run. And that's what's so rewarding about the hobby, is that you can start with something like that. You'll get it to run. You'll have the thrill of having your own engine run, and then you can get better at it and build more complex engines as you go along. What you should not start with is internal combustion. Internal combustion is much, much finickier about tolerances. They pretty much have to be built perfectly or they won't run. And also, if they're not built perfectly, they have a very strong tendency to become grenades and destroy themselves. And to make matters worse, the smaller the scale, the more critical all of the tolerances get, because you're talking about percentages of the dimensions of the parts here, right? So when you see these models on YouTube of V10 gasoline engines that are this big that people have built that run, massive, massive respect, because that is incredibly difficult to do. Internal combustion is very fussy and they are difficult to make run. So that can come later, but start with steam. How do you use 3D printing in your shop? Honestly, I don't use it a lot. I'm kind of a 3D printing rookie, and I don't find a lot of uses for it, partly because my 3D printer is very old. It's an almost 10-year-old printer-bought metal, which was a very nice printer in whatever, 2012 or something. I don't know, whenever that thing came out. It's 10 years old because I know I got it on my birthday. It was good for the day, but by modern standards, the print quality is very poor and the speed is very low, and it's very limited in the materials that it can print. So I don't want to judge the entire field of 3D printing based on my experience with that machine. But with that machine that I have specifically, I don't do a lot with it because it is kind of limited. So I print organizer trays for bolts and a few things like that here and there. I have 3D printed funnels. That's actually really nice. I like to do that for my steam engine, for my boiler builds. I'll 3D print a custom funnel that threads onto the safety valve to pour water in. little things like that. It's nice for that. So I would probably use it more if I had a better printer. So I can't speak to, I know a lot of machinists do use 3D printing for fixtures and holding jigs and stuff. I just haven't done any of that because my 3D printer just isn't good enough, I don't think, to do that kind of stuff. The prints that it makes are weak and not very accurate, and so it's good for what I use it for. But have you ever considered a shaper? Almost daily I've considered a shaper. Much like the rest of the internet, I find shapers delightful. They are incredibly charming and fun machines. Practical? No. As the old machinist joke goes, you can make anything except money with a shaper. But I would love to get one because they are so fun, and I'm not in a hurry. So, back in the day, I think in the 60s, Atlas made a hobby-friendly desktop-sized shaper. They didn't make a lot of them, and they're very hard to find now, but if I ever tracked down one of those, I'd be pretty excited about it. But I am actually probably going to build a shaper. Almost certainly I'm going to build a shaper on this channel. A viewer a while back sent me a casting kit for a hand-operated shaper, like kind of a small desktop hand-operated shaper that could also theoretically be powered. So I do plan to build that kit here on the channel at some point. It's a very big project, and some of the castings are pretty big. I honestly don't know if I'll be able to do it on my machines or not, but I'm going to try, at least. I might need a shaper for it. It's the classic shaper and shaper problem. In any case, watch out for that one coming soon. Where do you get metal stock? I did a video a few years ago on buying metal, and if you live in the States, I think everything in that video is still true. I would still buy metal that way. I now live in Canada, and so things are a little different up here. For example, one of the things I used to recommend was eBay. Because of USPS flat rate shipping boxes, there's quite a vibrant scrap metal market on eBay. And so I used to buy a lot of metal that way because, of course, when weight is no object, you might as well just mail scrap metal to people. I once ordered a 20-pound steel bar, and it arrived in what I think were the remains of a Tyvek envelope. It was fine because it's a 20-pound steel bar, but I do feel bad for everybody else's mail that day. It was probably not fine. But that market doesn't exist in Canada. It's different population, different geography, just same system doesn't quite work up here. These days, mostly I buy my metal stock at McMaster Carr, which obviously I know all of your wallets just cringed at that. It's certainly not the cheapest option, but they have pretty much everything, which is great, and it's very convenient, and the shipping is really fast, even to Canada, so it's really hard to beat them for those two reasons. If I wanted to go cheaper, there are other options. For example, my local welding shop will order just about anything I want. So, sometimes I will go to them for bigger stuff, especially if I need a big chunk of steel or something. I'll just go to them and say, hey, I need this and this. Can you order it? It just takes longer. There are also some mail order metal suppliers here in Canada, but again, it just takes longer, and they don't have all of the selection that McMaster Carr has. So that's kind of become my go-to. What's after the Pennsylvania A3 switcher? That's a very good question. My goal has always actually been to build Kozo's new Shay. The Shay is by far my favorite locomotive. I love geared logging locomotives. They're incredibly fascinating machines, and the Shay is the best of that genre by far, I think, and Kozo's model of it is especially good and very approachable, very buildable, so I would very much like to build that. I started with the Pennsylvania A3 switcher, however, because I recognized that my skill set when I started was definitely not at a place where I could probably have done it. Locomotive building is a whole other genre of skill set beyond building basic stationary engines. So I wanted to build up the skills to work towards the Shay. So the Pennsylvania A3 switcher was an obvious place to start because it was specifically designed by Kozo to be a beginner locomotive build. So it's been a very good learning experience for that. Hopefully I'll still have the motivation for locomotive building by the time that one is done, and I would like to build Kozo's Shay. We'll see. I have lots of other big projects that I want to do too, though. I've got some other big tool builds and some other big stationary engines. I've got a casting kit for a triple expansion engine that I want to build. I've got the shaper kit. I've got some other stuff. So, and I'm probably going to need a bit of a break from big projects after this A3. It's been such a marathon, this build. So I'll probably take a little pause. and we'll see where I go from there. I would also love to build the Shay in a larger scale. I would love to go to 5-inch gauge, or 4 3/4, as we call it in North America. The limiting factor there is the boiler. I don't think I can currently build a 5-inch gauge boiler. Boiler build difficulty goes up exponentially with size, and you start to need multiple people and multiple torches, and you have a lot of stay bolts, and things get very difficult. And I'm not sure I'm up to it, or if I have the equipment and skills to do that. So we'll see. I might consider buying a boiler. There are people who will make custom boilers for you. They are very expensive because it's a very valuable and rare skill to do that. So, people charge a fair price for them, but it's expensive. So we'll see. I'm still thinking about that. What do you think are the defining characteristics of your channel? That's an interesting question. I'm not the best at anything that I do here, right? I'm not the best machinist on YouTube by far. I'm not an expert on anything that I show. I just want to make content that's approachable. My main thing is I want to lower the intimidation bar for people to try all of this stuff. Nobody's born knowing anything. Nothing in this world is magic. Anyone can do all of this stuff. I think a lot of us are just intimidated by seeing experts do it. So my goal is always just to bridge that gap between the person who knows nothing and the person who knows a little and can maybe, hold your hand and at least bring you up to where I am. And then maybe you can sail on past me and head up onto the lofty heights of those above me. That's all I hope to do is bring new people into all of these hobbies and make them feel comfortable, make you feel like you can do it, because you absolutely can. If I can do this stuff, anybody can do this stuff, hands down. And, just share my learning with you. How do you manage feeds and speeds? I think specifically this question is about encountering unusual situations. So the basics of speeds and feeds I've covered in my lathe skills playlist. I have a video on this topic. And I think when starting out, it's helpful to go through that video where I go through the math of how to calculate what the technically correct speed and feed is for a given cutter, a given diameter, and a given material. And that'll get you in the ballpark, and then you'll see what correct feeds and speeds feel like. And once you know what it's supposed to look and feel and sound like, then you can adapt from there. So then now, a couple years later, when you're cutting something you've never cut before and it's cutting weirdly, you know what it's supposed to sound like or what it should look like when it's cutting properly, and you develop the instinct and the feel for what to try adjusting to make it cut better. So it's a lot of experience and making a lot of chips, but at least in the beginning, you can do the math and that'll get you close. And as I always say, in the hobby lathe world, we're generally cutting things less than 1 inch in diameter. Run everything at 600 RPM, 600 to 800 RPM, let's say, for your first year, and you'll probably be fine. Most things in the hobby size range are going to cut fine at 800 RPM. What's your process for creating an order of operations? I guess like most people, if it's a simple enough part, I'm just going to think it through in my head. That doesn't get me very far, though. I'm actually not very good at holding 3D things in my head and rotating them around. So beyond that, I'm going to pretty quickly sketch out a little series of steps on a Post-it note or something. Just draw a picture of the part at different stages and think through it that way, and picture, okay, after I make this cut, how am I going to hold on to it to drill that hole? And then that hole needs to be the reference for this corner. So then how am I going to, set that up on the mill? And just kind of think through the process in your mind. And the more carefully you think through every step that you're going to be doing, the better your order of operations is going to turn out to be. But there's still things you didn't think of, and there's always a lot of adaptation as well. I'll get into step 5 of my 10-step process that I thought I was going to do and realize I missed a detail that, I actually have to drill that hole first because of this reason. And so now I've got a weird part that I have to hold on to. So now I have to make a fixture to hang on to this weird part because I didn't anticipate this problem. That's going to happen anyway, but it's a lot of experience again. You learn little tricks the more you do. So for example, you learn angled cuts should usually be made towards the end, because as soon as you've got angles on the part, it's hard to hold on to. Cross holes in round things should usually be done first, because you're going to change the shape of that cylinder, and as soon as it's no longer a perfect cylinder, it's going to get hard to hold on to. So you learn little rules of thumb like that help. And like anything else, you do a lot of it and you get better at it. Of all the homemade jigs you've made, which is the most useful? Probably the cross-drilling fixture has been incredibly useful. That's one of those tasks that's fairly difficult to do well without a jig, and with a jig it's incredibly trivial, so that's a big one. Any kind of fixture plate is always going to be a big win. The round one I made for my rotary table has been massively useful. I have one that I bought, or actually was donated from Dayton CNC Products. It's a commercial one that I use in my mill. That thing is great. Any kind of fixture plate for model engineering is always going to be great because we work with a lot of small and weirdly shaped parts, so those things are always helpful. Do you have any experience with vertical milling attachments on the lathe? I do not, but I would actually like to get one and play with one, because there are times when a vertical milling attachment is actually easier to do an operation on than the milling machine is. A good example of that is slitting saws. Slitting saw setups on the mill are always a little weird because you always end up holding the part sideways on the side of the vise or something, and it's difficult to get it aligned, and you don't have enough reach on the arbor, and the vise jaw is in the way. Like, it's always a little awkward. Whereas on the lathe, if you have a vertical milling attachment such that you can hold and position the part quite easily on the cross slide and just stick that slitting saw in the spindle, you've got yourself a little metal cutting table saw. Easy peasy. So it's definitely something I'd like to get for my lathe and play with. What are your thoughts on doing more YouTube collabs? Oh, I definitely like to do more. They're always fun. I think the last one I did with Rex Kruger, he's got a woodworking channel, and I helped him make some turning saw pins for a vintage bow saw, and that was a lot of fun. A good collab has to have a certain chemistry, like it has to benefit both channels. So ideally you want to be kind of comparable in channel size. One can be a little bigger, a little smaller, but and the project, ideally, it needs to not be a contrived project. It has to be something that, you know, both of you need, and working together will be better than either of you doing it alone, kind of thing. If you try to force it, then it just doesn't end up working very well. And there has to be no time pressure on it. Even a collab between two people is enormously time consuming. Both of you have completely different production schedules, and you have to mail parts back and forth, which takes forever. And then there's production delays, and things might go wrong, and you have to redo something. And it's, you know, the simplest of collabs sometimes takes 6 months. It's crazy how long they take. Do you ever wish you had a more powerful lathe for the work that you do? Not really. I mean, my lathe is 1 horsepower, 750 watts or whatever, pretty standard for hobby work. Horsepower is never really a problem, right? You run out of rigidity long before you run out of power on these, especially these small machine tools, but probably on most machine tools. I think power is easy. Horsepower is easy to get. It's rigidity that's the problem. The one exception to that is this lathe that I have would really benefit from a back gear. I've often said that I think these modern Asian hobby lathes that we can get are generally better than the classic 60s ones, the South Bend 9 inches and the Atlases and so on. The build quality on them, we have hardened ways and power cross feeds and standard spindle tapers and all these things now that those old lathes didn't have. So they are generally better machines, I think, for the money. But the one thing those old machines all had that the modern hobby lathes don't is a back gear. And what that means is that when turning large diameters, you're slowing the spindle down with gearing, which means you're multiplying the torque, which is exactly what you want to happen when turning a large diameter. When you slow down the spindle with a belt drive and a DC motor, you're losing all of your torque at low speed. And so, yeah, I can run my lathe at 100 RPM, but it doesn't have enough torque to actually take any real cuts. So I've learned to work around it. I don't often turn things in large diameters. If I did, there's things you can do, like I could replace the motor with a 3-phase and put a VFD on it and so on, which would allow me to run slowly without losing torque. There's things you can do, but it's just not been enough of a problem for me to worry about. But, you know, a back gear would be nice. This person asks, I always over-engineer everything. Do you have any suggestions to be more frugal in that respect while still building things to last? Yeah, this is pretty much a disease of YouTube and also hobbyists in general. There's a sort of pride in building things incredibly skookum, using 1/4-inch plate for everything and making everything weigh 600 pounds is considered an unquestioned good. But I think there's a balance there that's often overlooked, because overbuilding things is actually just wasting resources, right? You're wasting energy and wasting materials. If something is definitely only going to be used for 5 years or likely to be used for less than 20, then building it to last 100 years is just a waste. So for some things, it's unquestionably good. You can build a hammer to last 100 years because when you're done with it, someone else will use it and it will go on and the materials that went into it are conserved. But building a laptop to last 100 years is a waste of resources. So, there's a middle ground there. I think knowing how strong things need to be, unless you're an actual mechanical engineer who can do the math, I think you can develop an instinct for it. Farmers are especially good at this. Most of my instinct for this comes from growing up on a farm. Everything on a farm is used to failure, so you very quickly learn how strong things need to be in order to last. And I think that that's developing that instinct is a way around needing to be a mechanical engineer. If you're not a farmer, what you can do is look at the built world around you, because other engineers have figured that out for you. You'll be surprised how thin a lot of the materials, for example, used are. Like, look at the desk that you're probably using for your computer at work or whatever. Jump up and down on that thing, it can hold 1,000 pounds, but it's probably made with like 50 thou wall tubing. It's incredibly thin, but it's just as thick as it needs to be. It's very efficiently built, and the structure of it is designed to hold that weight with thin wall tubing, and they know exactly how strong that thin wall tubing is and where to put it and how long the spans need to be between supports and so on. So you'll pretty quickly find that things don't need to be as heavy as you thought. You don't need to build your workbench out of 3/8 wall tubing. That's ridiculously overbuilding it, really. So look at the world around you and see how other engineers have built things, and you can build them a little heavier than that if you want, just for a little sense of pride and a sense of making things last longer. But thick wall tubing is pretty expensive, so think about that too. Next up, I've got a list of things that I've answered in previous Q&A videos. So at the end of this video, there will be a link to the playlist for all of my Q&A videos. So if you have any of these questions, go ahead and look at the other videos in the playlist. These include what was your life before YouTube? How did I get into machining? What was my background? What's my education? Where will I run the Pennsylvania A3 switcher when it's done? Does being a software engineer influence your machining? What's my past history that I've alluded to with racing cars? All covered in previous Q&As, so go check them out. I had a viewer ask for a little tour of all of the steam engines that I've built so far in my humble, nascent model engineering career. This is the family tree as it currently stands. This is the very, very first steam engine that I ever built, and it runs like a champ on air. It's a little wobbler, of course, because like I said, that's where you start. And this is built from drawings on a site called Steve's Workshop in the UK. I'll link to him below. He's got a really nice site with drawings for engines like this one. I actually built this engine twice. This is a slightly different version of it that I built later on, just for a little more experience and to try out some techniques, and kind of working on my own design for a similar wobbler. So I was experimenting with a few things. That's these two guys. This guy runs quite well on steam. This guy really only runs on air. The piston tolerance is a little too tight on it, and if it runs on steam, it seizes up after a few minutes, but you can run it on steam briefly at least. These little wobblers are single acting, however, so the bottoms of the cylinders are unsealed. So if you run them on steam, they do make quite a mess because they pour steam out of everywhere when they're running. This is the first engine that I built from a casting kit. This is the PM Research PM1 stationary engine. This is a really great starter engine. The castings are really, really nice. There's no operations in it that are too difficult. It's a nice size. The parts on it are not too big and not too small. So yeah, this was definitely a great place to start for casting kit engines. This is by far the biggest steam engine that I've ever built. This is the PM Research PM number 5 vertical steam engine. It's rated at 1/4 horsepower. But of course, the power rating is not for the engine, it's really for the boiler, because it's the boiler that makes the power. So while this engine could run up to 1/4 horsepower boiler, I do not have the ability to build a 1/4 horsepower boiler. So it's a really, really neat engine. I don't know if I can build a boiler big enough to run it. I'm going to build a big boiler that can at least idle this engine. I won't be able to run it at full power, but I would like to run it on steam at some point with some sort of boiler, so we'll see. Stay tuned for that. But I do have a playlist on building this. This was quite challenging because of the size of the components. This was definitely right at the limit of what my small machine tools can do, but I did manage to make all the parts on my little machines with a lot of creativity. So there's a playlist for this guy. There's of course a playlist for the PM1 as well. This guy I have documented on my blog. I don't have a video, but I did document this build on my blog, so you can see that if you'd like. This boiler here is actually the second stationary boiler that I built. Well, third technically, because I scrapped one of these while I was trying to build this one. I made some pretty epic failures on the silver soldering of the boiler shell, as you'll see if you watched the playlist for this boiler, which is also on my channel. The very, very first boiler that I ever built was an electric stationary boiler. That's, again, documented on my blog, not here on the channel because it predates YouTube. But if you'd like to see an electric boiler, that is something that you can build. It's great because you can run it indoors. There's no fumes, there's no gas, there's nothing burning. So it's a really nice boiler to run little engines in your kitchen on. But I don't run it much really anymore because it was my first boiler. A lot of the silver soldering on it is pretty sketchy and I don't really trust it. So yeah, this is my go-to these days for running engines like this. This boiler is big enough to run all of these engines except, of course, the big beast over there. I also have drawings for this boiler on my Patreon if you are interested, and also in the video series for this I go through the design process, how I decided how big it needed to be, how big the fire tubes should be, how many fire tubes, how thick all of the copper needed to be for safety, all that kind of thing. All the calculations and everything are all gone through in the video, so go check that out. And then of course we've got the A3 switcher back here in the back, quietly stealing the show, and this of course will be by far the coolest thing that I have ever built when it is done. I hope your questions got answered in this little Q&A. Thank you very much for watching. Thanks to my patrons for making it all happen, and I'll see you next time.